we're going to finish up the 2.6, finishing up 2.6. So we're looking at piecewise linear functions. And the piecewise linear function, so up until now, piecewise functions have had multiple parts to it. The piecewise linear only have one expression in them, but that expression makes the parts. Does that make sense? It will in just a minute, if not. So it contains a single expression. And a type of piecewise linear would be a step function. And a step function makes a graph that looks like you're going up steps. That's why it's called a step function. It consists of line segments. Visually, it looks like steps. So what we're going to do now is look at a type of step function or a type of piecewise linear function. It's called the greatest integer function, but I don't have enough room to put that, so I'm going to wait for you guys to finish writing this so that I can turn my paper. Okay? So we're looking at the greatest integer function. Greatest integer function is one kind of step function. Makes these little brackets. I know that looks kind of weird. You'll see it. It looks like a double bracket connected together. Something like that. And this says the greatest integer less than or equal to x.
What kind of bracket is that?
I just said it was a double bracket. It looks like two together is what it looks like in writing. Looks like two are connected together. They're very hard to draw. So greatest integer less than or equal to x. So if I ask you for the greatest integer of 3.2, if I ask for you the greatest integer function of 3.2, what integer would it be?
4 or 3. 3. Or 3. Oops.
3. Does everybody agree? The greatest integer less than or equal to the value. So the value is 3.2. So it's either going to be 3 or it's going to be 4, well, 4 is greater than, so it has to be 3. What about negative 4.6? What is the greater integer function of negative 4.6?
Negative 5.
Negative 5. Could have been negative 4 or negative 5. Negative 5 is the less than, right? Okay. So let's look at its parent function so that you can see what it looks like on a graph. So the first thing I will talk to you about here is if I plug in an integer, it's going to equal itself, right? Because of that equal to part. Does everybody agree? So if I plug in 0, I'm going to get 0. And if I plug in positive 1, what am I going to get? Positive 1. And if I plug in positive 2, I'm going to get positive 2. If I plug in positive 3, what about my negative numbers? If I enter negative 1, what am I going to get? And if I enter negative 2, what am I going to get? Does everybody see what's happening there? If it's equal to, I just put that integer as my y, okay? But what about all the values that would still revert back to those integers, okay? So if I want to get 0 as my greatest integer, what values would revert back to 0? Give me some values that would be 0. 0.2 would be what? What else?
0.3.
Give me fraction. 1/2.
1/3.
1/3. Anything fractional, but not equal to what? 1. So it's going to be everything from 1. 1 is an open circle down to 0. Is everybody with me? All those are fractions that would revert back to 0. So what values would revert me back to 1? 1.5. Anything below what?
2.
Anything below 2. So it could be 1.9999999, that included, but not 2. So 2 gets the open circle, and all those values less than 2 will revert back to 1. Still with me? Do you have a question? Because 1.5, the closest one would be less than would be 1. That's what this says. Greatest integer less than. So 3.2 went back to 3, right? So 1.5 would go back to 1. Do you agree?
If it was 3.6, would it still go to 3?
Yeah. If it was 3.99999, it would still go back to 3. But when it changes to 4, what would happen? It goes to 4, right? Now we're moving on to 4. So everyone will go just to the integer coming up next, but not that number.
Why wouldn't you just do the exact numbers?
It's a function. They're just describing a specific function. This is called the greatest integer function. And so if they ask you for the greatest integer function of a number, you have to know that it reverts back to the number before. You with me? What about -1? Where would those numbers come from? Anything less than who?
0.
than 0. 0 is the integer before it. And then -1 to -2. So notice what the graph looks like. Looks like steps. This is why it's called a step function, because it looks like steps. That was it. That's it about it. That's all you have to know about it. You have to know that if they ask you for the greatest integer function, you're talking about the value below, less than or equal to, right? And you need to know that its graph would form a step function. Yes? Okay, let's talk about absolute value then. Am I still on the screen?
Yeah.
I'm on the screen there. Okay. Absolute value function is just a function that contains an algebraic expression with an absolute value symbol. Alright, so we're going to talk about its parent function. So we'll start out with what the parent function looks like. F of x equals the absolute value of x. It is defined as a piecewise function. So this statement says that f of x is equal to x if x is greater than 0, 0 if x is equal to 0, and negative x if x is less than 0. Think about numbers that are less than 0, they'd be negative numbers, right? So if they're less than and they're negative, a double negative is going to make them what? Positive. So this is just defining that absolute value term. Is everybody with me so far? Okay. A couple of things you need to know about it. Its graph is V-shaped. The domain of absolute value is always all real numbers. It continues to grow out to the left and out to the right like quadratics do, except for it makes a V instead of the U, so it's not so curved at the bottom. It's a very strict U. That'd probably be why your Algebra 1 teacher may have taken points off if you didn't make it curve, because the quadratic is a curve where the absolute value is a strict V. Does that make sense? Okay. The range works just like quadratics also. You could write it as the y's that are greater than or equal to 0, or you could write it in an interval notation as all the values 0 to positive infinity. One of the two ways, whichever works for you. It intercepts the x and y axis at the same points. We're talking about the parent function. Okay, this is very important that you know that we're talking about this specific equation right here, where x is 0 and y, or better known now as f of x, is also 0. And the function is not defined where y is less than 0. The function is not defined at y is less than 0. Why could it not be defined at y is less than 0? Am I ever going to get a negative answer if I plug in a number here? So this parent function, I'm never going down below where I'm getting negatives. You with me? So that's where we're talking about. Now I'm not saying if you make some adjustments to this equation, like if you add 2 on the outside or on the inside, if you make some transformations to it, there may be some less than values, but that one will have some restrictions also. There will always be restrictions where this is put into play. So let's look at a graph. Because I am looking at 3 pieces here, I'm going to make 3 tables. Every one of them are going to start with who? 0. Every one of them are going to start at 0. I'm going to start with the first one. It says x is greater than 0. So what other x's could I have here? 0 and who? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough room for all those, so I'm just doing a 1 and 2. And so it says that if I have these values, that my y is equal to my x, right? Y equal to x. So 0, 0, 1, 1, 2, 2. Just following what it says. Okay. On the second one, it says if x is 0, then y is also what? 0. That's the only point I can put there. It's the only point that y x is 0. There are no other values where x is 0. Does everybody agree? And then on the third one, where x is less than 0. So 0, -1, -2. When I plug those in, I'm going to take the opposite of x, the negative of x. Does everybody agree? So the opposite of 0 is just 0. The opposite of -1 is +1. The opposite of -2 is 2. So now I have values that I can put on the graph. Does everybody agree? Okay. Let me finish my graph because I got sidetracked here. But I got them anyway. All right, so let's start with the one in the middle. 0, 0. You with me? On the left side, I've got -1, +1, -2, +2. On the right side, I've got +1, +1, +2, +2. And I can use my ID to create my V shape. questions about what I've done there? So what we're going to look at is some transformations based off the graphs. I'm going to show you how to find the graphs, and then we're going to look at how it changed from this parent function. Is everybody with me? Okay. We have it? Guys, we're quite a bit behind my other classes. I don't know how that happened.
The freeze on the lockdown. Tuesday's freeze.
Oh, the freeze, that's what it was, you're right.
It cut into our time quite a bit.
I've slept a few times since then, so I don't remember. Alright, so we've got this function, f of x equals the absolute value of 2x minus 4. And the first thing I'm going to do is identify some values for x for which I can find their values of y. I always like to start with something like this because if, oh sorry, ignore that. That dot's a mark out. If I start with these values and I don't get what I need, I can always add to the other ends fairly easily, or whatever end I need to add to. Is everybody with me? With absolute value, it works like quadratic. I'm looking for a pattern. Okay? I'm looking for a pattern. So if I plug in -2, -2 times 2 is -4. The absolute value of that is 4 minus 4 is 0. Should 2 work the same way? If this pattern is where it's supposed to be, it will. Okay, if I'm not in the right spot, it might not. Is everybody with me? So just to check, 2 times 2 is 4. Absolute value is 4 minus 4 is 0. So it looks like I might be in the right spot. -1 gives me, -1 times 2 is 2 minus 4 is -2. And +1, does it result in the same? Yes. And then 0 gives me 2 times 0 is 0 minus 4 is -4. So I'm going to put this on the graph as such. At -2 and +2, I'm at 0. -1 and +1, I'm at 2. And at 0, I'm at 4. So now I can use my handy dandy ID. And just for visual sake, I'm going to sketch on here the original parent function. I want you to note what happened between the two. If you sketch it, that's fine. It's not the solution. I just want you to see this. We will talk about transformations during the next section, but I just want you to see What do you note about the two, the difference between the two? The slope of the lines, one's skinnier, the other one's wider. So this 2 right here actually made my graph go whoop, okay? Then what else do you note? The y-intercept is where? So it went down -4, looky there. Interesting, right? Those numbers all mean something, and when we get done, you will be able to look at the graph and look at the equation and know what the graph looks like without graphing it, without doing any of this. Is everybody with me? The bigger the number, the narrower it gets. The fractional number will make it go out wide. This number makes it go up and down. A number added right here after the X would make it go side side. We're gonna look at that in just a minute. For now though, this is what I'm looking for. I want you to create a table and put it on the graph. Then think to yourself, how did this change from the original one that we drew? Does that make sense? Because if you start visualizing them now, it's a lot easier later. Let's talk about the domain of the orange one. What is it? Remember I said that's always going to be all real numbers. It's got those arrows going out. It's going to continue going left to right. Quadratics, linears, absolute value, always, always, always have a domain of all real numbers. What'd you do?
It fell.
Okay, are we good?
Mhm.
You sure?
Scared to let go.
Do I need to come fix it?
There you go.
Okay. Can you still see the screen? Okay. All right. And then the range. What do we know about the range? Well, the original one was everything greater than 0. What's this one greater than? -4. So it's all my y's greater than or equal to -4. Or I could write it as -4 to positive infinity. All right, I want you to do the same instructions with both of these. Same instructions with both of these. get where you only found one side, find the other, use some other numbers to get that other side. If you've got one going this way, then look for numbers going this way, right? I would always start with that. That's always just a good place to start. The numbers I use are just a good place to start. Then you can kind of see, do I need to get some positive more values or do for X, or do I need some negative more values for X? Or do I need any at all? 2 points make a line. Put it on your graph what you got and see where you need to go. That always helps. There's 2 problems up whenever you finish the first one. Yep. Okay, thank you. Chance, you have a dentist appointment. Make sure you sign out through the front desk before you go to your vehicle. Should we pause it right there while we're working? Part of your issue here is that you guys want to rush through some things and you're not paying attention to detail. That's a problem. All right. The first thing is, if you tried those numbers the first time, you realized that you only had one arm. You had to find the other side of the V, right? So I added 3 and 4. That gave me a few more points on that other side. Gave me my pattern I was looking for. So once I got that, I knew my domain. I could have done my domain without even graphing it. Does everybody agree? My range, however, I had to see what I was greater than. I didn't go below 0, so it was everything above 0, right? Looking at the second one, however, what happened to my graph? It flipped it. By the way, this negative sign on the outside, that's what flipped it. That's called a reflection. You'll see that here shortly. And so what happened with my range? My range now is not greater than, it's less than the positive 1. So make sure you check that range. That was a big key on this one, was that range is much different. Got to pay attention to how you're reading the graph on that. That's what I'm seeing the most issues with on the homework, is people not paying attention to the itty bitty details. Any questions? Homework due tomorrow.